We're going to take a look at quadratic equations and finding the general term of a quadratic equation. So first thing we're going to look at is how can this be asked? What ways can we be asked this? So if we look at these three different ways here, and then the last way is going to be the question we're going to answer. So the first one is find the general term of the quadratic pattern. So this is as well, could also be asked as a patterns question from sequencing series. So find the general term of a quadratic pattern. The next one then, write the following as an algebraic expression in the form, now there's a bit missing there, ax squared plus bx plus c. So write the following algebraic expression in the form of ax squared plus bx plus c. And the last way then is use the table to write the following as an squared plus bn plus c, and again that should be an squared. So to be careful with, or being careful with this, sometimes when we're given a table to write with, the thing that we need to be careful of is they will give us certain terms of the quadratic. So for instance, you would be given that these are the x values and these are the f of x values. So like you're substituting into a calculator. But the values inside in it might be, we'll say minus 1, 0, 1 and 2. And then we might have, we'll go with the one that I have below, 5, 12, 23, 38. When we're doing this, when we're using this, we are using from term 1 upwards. So we are using 1, 2, so on and so forth. They're the values that we're going to use for this. So I'll show you what I mean in a second. But just remember, when you're given a table like this one here, you have to be using the values from 1 upwards. Because when we're doing terms, we use T1, T2, T3, T4. So on and so forth. We never use T minus 1 or T0. So I'll show you what I mean by doing this question here. So looking at this question then, here we have find the general term of the following. Now you did see this in Junior Cert before, so it should be something that you recognize. Find the general term of the following. So I need to write this then in the form of Tn equals an squared plus bn plus c. I need to write it like that. So that's my first step. I write that down. My second step then is to find this a value here. So to find the a value, now be careful, the a value is not the first term in this case, not like we would have done when we were picking out the a value for a geometric and an arithmetic pattern. In this one here, you're finding a is just the first part of this general pattern. So to do that, what we need to do is we need to find the second difference. So when we're finding the second difference, I'm going to just move this up a small bit. I need to find my differences. So for instance, I need to find the difference from here to here, from here to here, from here to here, and from here to here. I need to find what that is. So when I do that, I find that this one comes out to be, if I write in, I'll do this one in red, that's 7. The next one is 11. The next one is 15. And the next difference is 19. Okay, so that's my first difference. I need now to find my second difference. So my second difference is how I'm getting from here to here, here to here, and here to here. So how I'm getting from 7 to 11 is I am plussing on 4. 11 to 15, I'm plussing on 4. And then my last one, I'm plussing on 4. Okay, so my second difference is equal to 4, and that's something that we're going to use. So for my first step, again, we wrote out the general term. For the second step, I'm finding a, which is the first part of my general equation. So when I'm doing this, then what I'm doing is I know that 2 times my a value will equal my second difference. All right, so I can say from there then that 2 times a is equal to, and we found our second difference was 4. So divide both sides by 2. My a value comes out to be 2. So my third step then will be to write out my Tn is equal to instead of a now, I know a is 2. So 2n squared plus bn plus c. I'm just writing out this bit here, down here. Okay, so that's my third step. Finally, my fourth step then, what I have to do here is I have to pick out, this is where it's important to make sure that you're picking out what T1 is, and I need to pick out what T2 is. So make sure you're not just taking the first and second one from the pattern. If you're given a table, make sure that you're taking the term 1 where x was 1 and where x was 2. So in this case here, because they've just given it to us as a pattern, I can take it that this one is term 1 and this one is term 2. However, if that was written in a table, we'd need to be careful and make sure that we're taking 1 and 2. So I can say from here that my term 1 is equal to 5 and my term 2 is equal to 12. Okay, so that's term 1 is equal to 5, term 2 is equal to 12. And what I'm going to do with that is I'm going to say, well, I don't have T1 or T2, but I do have Tn from earlier, and that's 2n squared plus bn plus c. So I can see that 1 has changed to be n, or 2 has changed to be n. So what I'm going to do is I'm going to do just that. I'm going to write that T1 is going to be 2n squared, sorry, go back to this. Instead of n, I'll sub in the 1 then. So 2 by 1 squared plus b by 1 plus c. Okay? Now I'm just going to zoom out a small bit so I can get a bit more room. Okay? And I know that term 1 is this one here. Okay? And I can just tidy that up a bit. And I can say that term 1 is equal to 2 plus b plus c. All right, I can do the exact same thing then with term 2. So if I do term 2, I know instead of my n, I'm writing in a 2. So it's going to be 2 by 2 squared plus b by 2 plus c. So term 2, and I tidy that up, is going to be, 8 plus 2b plus c. Okay? So now I have my term 1 and I have my term 2. But I know that term 1 from earlier, I know term 1 was equal to 5. And I know that term 2 was equal to 12. So I can say from that, if I zoom out a small bit again, need a little bit more room, it's quite a big question. I can say here that 2 plus b plus c actually equals 5. And I can say 8 plus 2b plus c actually equals 12. Okay? And from there, what I'm going to do with those two things is I'm going to do a simultaneous equation, and I'm going to solve to find my b and my c. Okay, so I'm going to go over to this side here, and I'm going to solve to find my b and my c. I'm going to say that that's b plus c equals 5 minus 2, so it's going to be 3. And then the second one's going to be 2b plus c equals 12. Take away 8, that's going to be 4. I'm going to just change the signs on one of them, so multiply by minus 1. And I'm going to have them two cancel out, and I'm left with b is equal to 1. I'll substitute back into one of the lines. I had b plus c equals 3, so that's 1 plus c equals 3, so c is equal to 2. So the two values that I have here was that b is equal to 1 and c is equal to 2. So that I can sub them now back into my original equation. So if I go back here, there's my whole question. And I can see that my answer is going to be Tn equals, I had my a from the step 2 up here. That was 2n squared. My b is from over here. Plus 1n, and then my c is from here. Plus 2. And there is my general equation then. Didn't need to write the 1 either. I could have just left out that 1, didn't have to write that. But what that general equation tells me is that if I sub 1 in there, I am going to get term 1, which was 5. If I sub 2 in here, I'm going to get term 2, which was 12. If I sub in 3, I'm going to get term 3, which is up here. That is 23. If I subbed 4 in, I'd get my 38. So that is the general equation of this pattern here. And then same rules apply if I was using a table. Just make sure again that you're using your term 1. So the x value is the 1, take the y value from that one.